I wanted to show you the setup I have here now. It's just so much easier to do this sort of thing in the classroom. And so this is what I'm working with. The first situation I'm going to film is taking a strike and dip of an overhanging surface like this one. So this is the situation of an overhanging surface, right? Considering that that is north and that this surface dips to the northwest, all right? If that's north, this surface dips to the northwest, then I'm going to want to express the strike toward the southwest so that my right arm is in the direction of the dip. I want to emphasize again, it really doesn't matter. I can either hold the compass this way or this way, but I'm quite certain that if I hold the compass in this orientation, you can better see the bullseye level right there. At least I'm hoping that's the case, because it's very important to all of this. So when I take the strike here, I'm going to put this edge of the Brunton firmly against the underside of that surface. At the same time, I'm going to make very certain that the body of the compass is level, as indicated by the bullseye level. That guarantees that that edge of the Brunton against the surface is a horizontal line. All of that satisfied, I can now read the strike from this end of the compass needle, and that strike is 234 degrees. 234 degrees is the strike of this surface. The task at hand now is to determine the dip of this surface. That is this angle in the dip direction. To do that, I am going to use the spirit level mounted on the clinometer, and I'm going to manipulate the clinometer using this lever on the back of the Brunton. All right. Okay. You'll notice that if I try it this way, I cannot get the clinometer arm into an appropriate position, and the scale for the vertical angle is on the wrong side of the Brunton. What I have to do is to hold it this way. I'm holding this edge of the Brunton against the surface, all right, in the dip direction, and then I'm going to come around and manipulate the clinometer arm using that lever on the back side of the Brunton. Doing it until I get the spirit level, and that is accomplished right there. Okay, I can now read the dip from this scale, and that dip is 46 degrees. So the strike and dip of this plane, expressed appropriately using the right arm rule, is 234 degrees. That's the strike, and the dip is 46 degrees. So in my notebook, it'll be recorded as 23446. 3 digits for the strike azimuth, 2 digits for the vertical angle. Again. This plane dips moderately to the south-southeast. That is, it dips in that direction, to the south-southeast. Therefore, respective of the right arm rule, I'll want to record the strike off to the east-northeast. I'll add that this is an upward-facing surface. Therefore, I'm going to use one of these lower edges of the Brunton. And I could hold the Brunton either in this orientation or in this orientation, but my interest now is to make sure that you can see this bullseye level. So I'm going to turn it around this way, putting this edge firmly against the surface and making sure that the bullseye level is leveled. With all of that the case, the strike is determined to be 059 degrees. And that, as I mentioned before, is correct for the right arm rule. The strike is pointing to the east-northeast. It's also quite common to use a notebook. I have this notebook marked up with a potential strike line and a potential dip line. So if I did this, I would hold again this edge of the Brunton against the notebook now, which is in turn flat against the surface to be measured. At the same time, I'm making sure the bullseye level is level, and that the edge of the Brunton is parallel to the long line on the notebook. Here too, I note a strike of 0.59 degrees. The benefit of having these marks is that I then have a mark for the dip direction, and that'll be the next part of this. What has to be done now is to measure the dip of this surface. And recall that the strike was measured, as a horizontal line in the dipping surface. This time, we want to measure the dip from horizontal down to the surface, perpendicular to the strike. To do that, I'm going to put this edge of the Brunton compass against the surface. I'm going to pay attention to the clinometer this time and the spirit level, and I'm going to use this lever behind to manipulate the clinometer. If I do that, with that spirit level leveled, I see a dip of 44 degrees. Now that can also be done with the notebook. So the benefit of the notebook in this case is that it marks the dip direction. If this line had been established to be the strike line, then this line is rather perfectly the dip direction, and is simply repeating the process using that line. That is, I just leveled up the spirit level. It's level. The dip is right here at 43 degrees. Essentially the same as the 44-degree dip I just determined. This simulates yet a third situation that you may encounter in the field, and that is a plane having a very shallow dip. On this plane, the dip is off in this direction and the strike is off in this direction. But the dip is exceedingly shallow. It's only about 10 degrees, maybe a little more. And this is kind of problematic. I'll explain. This surface also dips, although at a very shallow angle, to the south-southeast, which means I'll want to record the strike to the east-northeast, respective of the right arm rule. The problem we're going to have is that with a surface that dips at such a shallow angle, when I put this edge of the Brunton against the surface and try to level the Brunton up, what happens is this ring that's raised on the underside of the Brunton hits the surface and prevents me from taking the measurement. To overcome this problem of such a shallow dip, what I'm going to do is I'm going to use the Brunton as though it were a simple level. To do that, I am going to set the clinometer to 0 degrees. And you might note right here that that is now set to 0 degrees. If I now take this edge of the Brunton and put it on this long line of the notebook and bring the compass up to near vertical, like this, all right? And then I rotate the notebook in an effort to make the Brunton level. If you can see the spirit level now, it is level. And with the Brunton set, the clinometer set to 0 degrees, what I've done is I've established that this line is now horizontal. Therefore, that line is my strike line. And all I really need to do is to align the compass nicely and very precisely with that line, level the compass using the bullseye level, and with that being the case, I now know that this has a strike of 0.55 degrees. Again, I had to do that because this ring interferes with the conventional way of taking a strike and dip. My approach was to first establish that this line is horizontal, therefore that line is a strike line, and then I just have to measure the compass direction of that strike line. Having determined that the strike line, this line, is 0.55 degrees in terms of its compass direction, that is the strike, what I need to determine now is the dip angle from horizontal down to this other line. Well, that's a simple matter because, again, I'm going to manipulate the clinometer with this lever, lay the compass on my book in that very specific direction, level up the spirit level. All right, so in this case, I see a dip of about 14 degrees. This is about the limit. That is, any dip angle shallower than this, we'll have to use a technique like I just demonstrated.